the model that is actually deployed over there, right, which is serving everything over there, right? And if that is compromised, everything gone. So there are a lot of researchers, machine learning developers are there who are developing those models day and out, right? And they are fine tuning that for certain applications and then deploying over there. If the model is reversed by an attacker, right? So that way they don't have to struggle for rest of the engineering cost. They can copy a model and sell the products over there.
When you change these weights, what changes on the ground?
Now, let's say if you go to the stock and eventually someone can tamper into the weight, right? And eventually the model is deployed. Everyone knows tomorrow the values are going to be so and so.
Yeah.
And someone tampers into the morning, right? The market is going to crash like anything.
And the attacker can book the profits. Right?
Yes, attacker can book the profits.
Tokenizer reversing, how relevant is it? And what goes into that? What were your challenges? And
storing some data which is not into training set. Meaning that, let's take an example of.
With the reversing, what could an attacker do?
Changing your weights, right? Patching that existing into in your deployment scenario. That is another aspect.
This means it could have huge geopolitical implications.
Yes. From a security point of view, a particular format has to be, custom format is much needed at this moment.
Any last words for passionate AI researchers?
Don't limit to application security. You have to understand the domain. You have to understand the mathematical.
And welcome everyone to this episode of Breakpoint. We have with us Yashodhan. He is a research scholar in MIT WPU. He has done his MTech in satellite communication and signals processing. The topic that he is speaking on at NullCon is reversing large deep learning models. Welcome to Breakpoint, Yashodhan.
Thank you, Lindu.
So, how has been your experience of the conference?
Yeah, so it's great to come over here. The thing is, NullCon is always, the research powered, and you get to know a lot of researchers, you meet a lot of researchers, understand the new topics from the security, not only from the app security, they cover embedded security, satellite communications, many topics are there.
Yeah.
And AI being now the hot topic, I can see some of the topics from that as well.
Yeah, so that stood out as very interesting for me. While we talk about so many issues in AI that's already started, we have top 10s of large language models and AI. I was looking at the abstract that you had for the talk, and you were talking about reversing beyond passwords, beyond keys, which are the general issues that many times people report. Can you give some examples of what is it that you are finding which is beyond the usual issues that we find in applications?
Yeah. To make this understand, right? So we have to understand how any AI lifecycle works or any data science life works where the intelligence is added over there. Eventually considering the requirement, the business requirement that you have or a product requirement that you have, right? Based on that, you need to have a data. Right? There is a lot of process of collection of a data from multiple sources. Then the next step happens is like you have to clean the data, rather you prepare a data so that you can build intelligence on that.
Okay.
Once you have this particular data ready in certain format, we do something called as a feature engineering or feature selection, meaning to get some key features or key points from the data that helps you to predict something out of it. And once this thing is perfectly ready, right, we develop a neural network model, which is what we call as an AI model, right?
Okay.
All these things are behind those things to create that AI model, which basically learns from that particular data. It learns those patterns over there. And once you have that pattern learned, you have to test the model, its accuracy, how it is performing. And then things from a business point of view, you need to deploy that model either on-premise or a cloud and give access to the customers for that, right?
Yeah.
So this is the typical life cycle of AI. Now, considering the models that we have, right? So those models are nothing but the mathematical functions, right?
Yeah.
So when we say a neural network, it's not an biological neural network, it's an artificial neural network, right?
Yeah.
So it has basically like mathematical functions, right? Statistical things where you have some weighted sum, you have some computation of collecting a data and you multiply with them something, you add them, right? And you apply some mathematical techniques to learn the patterns, right? Now, these things, what we have in neural network, the foundations of that, something called as a weights. The weights are something, they are called as a neuron weights in terms of artificial neural networks,
Okay.
which shows what is the strength of learning of that particular neurons, the artificial neurons in your neural network over there.
Network, yeah.
And they are the foundations of that particular model. The biases, the term that over here is like, that is a term used in terms of, having, if you have, let's say, 0, 0, 0, 0 output, right? How are you going to handle that? So you have some constant value added over there to handle the inputs in a proper way, right? So it's again a simple thing when we learned in the schools, like y is equal to mx plus c, the line equation, right?
Yeah.
That is a thought process behind that. So all machine learning thing starts with that y equal to mx plus c, and things are built upon that. Right? So these are the foundations for it, and then when we do the reversing on that, right? So generally, what happens is, if you look from an application security point of view, right? You have those external interfaces available to you of accessing those models' output, right? LLMs or whatever output your vision models you have, but eventually. The model that is actually deployed over there, right, which is serving everything over there, right, which is the core of all this entire, the infrastructure you have,
the
right?
heart of that,
the heart of that,
yeah.
right? Heart of that, right? That basically model contains all the intelligence, and if the model is reversed by an attacker, right, it basically understand the entire architecture in which the system has been designed. The most of the engineering cost from the business comes from developing the models.
Yeah.
Right. So there are a lot of researchers, machine learning developers are there who are developing those models day and out, right? And they are fine tuning that for certain applications and then deploying over there. And if that is compromised, everything gone.
Yeah.
So all your predictions and everything fall by. So that way, when you go back and understand those models, right, we see those weights and biases, how the different neural network architectures inside that, what are the weights are there, right? And attacker can tamper those weights, or simply some can copy those weights and create their own model, sell it to the customer. So that way they don't have to struggle for rest of the engineering cost. They can copy a model and sell the products over there.
So one of the things I wanted to double click a little bit here. So you said, I think what I got was two things. One is the weights and how they have also some formulae behind how that is. And the other part is the copying of the weights that you're talking about. So are you saying that the attacker will get to know the quote unquote algorithm behind this, because it might be a combination of so many of these formulae? Is that possible with what you're saying, or you're saying that just take the entire template of weights and then use it in their model?
Both things are possible.
Okay.
Yeah. So thing is, when you reverse engineer a model, you get to know what is the input, the size of input till the output, everything that is happening inside the neural network. Right?
Yeah.
That way, the entire architecture can be copied as it is. Right? Someone can develop their own architecture, understanding what are the functions, how they are connecting, the layers are connected. And inside that, you have each layers, we have those weights, right? They can also be copied. And, basically like NumPy files, someone can copy and over there.
So this will be like an entire intellectual property
for
the language models or any kind of data models that they are generating. Can you give one or two examples of what that would mean? So for the audience, just to understand, what does that mean for a sample model, for example, when they can, use this or abuse these kind of issues?
So now, when you look at AI for domain, right? So if you look at IT domain, we have a CI triad, C being the dominant over there, right? Confidentiality dominant, right? The dominant, right? If you go to satellite domain, we have the availability is dominant. They have a sequence of AIC. But now when you look at AI, the dominance is now ICA. Integrity is the topmost priority over there. Right? Now, eventually, once someone has that access to the model and how the architecture is done, right? Of course, the confidentiality is broken at that moment itself, right?
Exactly.
But now, eventually, once you understand those, the weights that already have, okay, one can understand how to tamper those weights. Meaning, at what layer by layer, someone can create the fuzzers and what level they want to attack to that neural network. One can do that. So that way, there is something called weight perturbations, meaning inside that you smallly change those weights, right, and try to poison the model itself, not data. It's a model poisoning part that you can do over there. So that way, both things are possible from the attack
Yeah,
perspective.
so just to simplify it for the audience, what I was trying to do, for example, it's a healthcare model,
Yeah.
right? So when you change the weights and biases, I think you've also talked about it a little in your abstract, and I'm sure in the talk as well. When you change these weights, what changes on the ground? If it's a health model, or if it is a model for banking or finance or trading, or you can have models for specific, or a language model.
Yeah.
What would that mean for them?
Yeah. So generally, the typical product or problem statements, you come with these things, right? Either you want to predict some values out of it, right? Like the stock markets, like you have to predict some values.
That's interesting.
Right? And also, other thing is like you classify something, whether this is the object, whether these are the leaves, this is a tree, right? This is something object detection, that classification problem comes into the picture.
Right. Yeah.
Now, let's say if you go to the stock and eventually someone can tamper into the weight, right? And eventually the model is deployed. Everyone knows tomorrow the values are going to be so and so, and someone tampers into the morning, right? The market is going to crash like anything.
And the attacker can book the profits, right?
Yes, attacker can book the profits. So there are different ways to do that, right?
Yeah.
So that is one thing from the stock market. From the dangerous things, consider self-driving cars. Now the self-driving cars, when they're when they're looking at the object and they start classifying the object, the safety goes haywire.
In milliseconds, I think that impact will be much faster.
Much faster. It's a safety issue.
So, okay, this is getting very interesting. One part which I also wanted to double click and understand better is the tokenizer reversing. So this is something I was also looking forward to learning. How relevant is it? And what goes into that? What were your challenges and what did you find?
Still, tokenizer is something, generally happens with large language model. But what is actually currently happening, right? LLMs are still one part of it. Okay? When you look at the current scenario, GPT-4o or whatever, right? They are something called as now multimodal models. Okay? Meaning they have capability of languages. They have capability of vision, meaning images, the videos, as well as they have capability of audio and the speech, right? So now they are trained for these different kind of features that you have, right? Tokenization is something being used in large language models, where the small, when you write some sentences, right? Eventually try to break into small words, right? To, create that kind of, simple words, they want to create a chain of thoughts to the neural network. They use something as a transformers, and to understand neural network, what is the relevance between the last word and the first word, right? We need to break that thing to understand the context over there, right? So this is how the tokenization works, that you break the words in small, that like hi, I am, whatever, right? So, or high five, if I let high five, right? So this hi means something else, and hi, I am, right? This means something else. So the relevance between the two words, right? They are very critical in that context. And that's what again attacker try to do from using the prompt and other things, right? You attack on the tokenizer part and try to manipulate the data that is going inside your neural network as well. Yeah.
So this seems pretty straightforward.
Yeah.
But when you look at actual attacks with the reversing, what could an attacker do?
Yeah. So as I said, like from attacker's perspective, the most thing is first of all copying your model, that is IP. Another, the weight perturbation, as I spoke about, changing your weights, right? Patching that existing into in your deployment scenario. That is another aspect. And another thing is about the data poisoning, or the backdooring part, where you are storing some data which is not into training sync, meaning that let's take an example of face recognition. The doorbells typically have the face recognition, and your the smart homes, your door open when you arrive at your home, right? And now eventually in the database, if an attacker tries to somehow put his face into the database, right? It is going to identify with my name as an attacker, like as my name, right? It compromises the identity of the person over there, right? As an image over there, right? And eventually it can, take the identity, bypass those authentication, and someone can get access of the home as well. So that was another threat for that as well.
So are these also belonging to tokenizer reversing?
No, tokenizer reversing is something more about languages. But if you look from the AI models perspective, these are the critical attacks that happens from a vision perspective, the different computer vision and those domains perspective as well.
Yeah, I think many of these, so because we are in security, we always think what is the security impact, but I think all of these are quite correlated, the way you are talking about it, right? So it is not just about that, your authentication will be compromised if you can, like data poisoning is such a big thing. If it does happen, it could have different kind of impacts, right?
Yes.
Starting from the accidents that we were talking about to mistrust, because these systems will then start trusting other systems, and they have these, maybe in some cases, tokens, and depending on what is being poisoned, that kind of data will impact on the actual issue that will be happening, right? While you were talking about weights and biases earlier, so one of the things that I was thinking was overall at a macro level, right? We are talking about the data, we're talking about the models, and you're going deeper into it, and you have this amazing subject that you were talking about earlier. What are the macro aspects of securing this? So while attack is quite fancy and all of us want to do that, I think we're already doing that for various models as researchers. Organizations that are both creating these models actually, and others who are consuming this. So what is your advice to them on how they actually secure AI overall? Is there a structured, methodical way that they should approach this?
Yeah, that's a good question. So when you look at, from a secure development lifecycle perspective of the AI, right? The first thing comes into the mind is like what basic assets of the AI are, right? So if you just break down what the AI, it has three major components. One is the data, one is the model that I spoke about, and the algorithms that are used, not exactly the AI algorithms, but feature selection algorithms typically used, that's supporting the AI, right? So there are three aspects: data, model, and the algorithms, right?
Yeah.
So this is something we need to protect against. So these are my main assets, and there are sub assets for that as well, right? So now, eventually, when you start looking from as a left shift approach of securing your AI, right? The first thing is you have to approach not in a traditional way. You have to look AI as a domain.
Okay.
Right. So you cannot think only from a stride perspective, creating a threat model. So you can map the threats to stride, but you cannot start going from stride.
And map
You have to
everything.
understand what does that AI is doing, and then later you map to stride. Companies should have some AI expert associated with the security team who can explain what is actually happening at the background, or how the system is working. It's beyond a typical deployment architecture. We have a cloud deployment and those things, right? So understanding how the AI system is working, what is the frequent need of the AI, because in AI what happens is we have ML ops, machine learning ops, where it's not only CI/CD pipeline, it is beyond that, where we need to train the model again over periodically, right? So that is another aspect of that. So eventually what happens is like you have to understand how the AI system is working, how that model is working, and based on that you can address those threats. So AI domain knowledge is much important in this case. And once you have that, you can map it to CIA or a stride, whatever framework that your organization is using, right? And based on that, you identify the risk associated with that. So the better way is using this NIST AI risk management framework, right? They have, I think, and also we have this ISO 42001, which is AI quality management system. It is more aligned to 27001, but mainly focus on AI as well, right? So that is something from a governance side one can do, starting from the organizations. Now coming to the technical part, as I said, like the adversarial training of that model is must to have. How you can tamper into the models, you try as much as possible with the with the knowledge of AI expert and with the security knowledge experts, right? Both come together and have these discussions. You can have a better adversarial training of that thing, so that it can filter out the unnecessary inputs, the malicious input that it is getting over there.
So the adversarial, just a little bit, I will want to talk about this adversarial training. So one is the training part, one is also the testing part, which means that there needs to be thorough testing around this.
Yes.
But there, I think, knowing systems a little bit, I think there will still be some room for improvement. I've seen many models improving on this part. Like if you've given them a specific prompt, over the years they know how to respond to it. more accurately in the sense of, you know, not being offensive, for example, is just one thing, but also not revealing personal information,
Correct.
not revealing information that will be used for frauds,
Yeah.
not revealing others' data or thoughts or, you know, other things in the way people, rather consumers of the system, might be using it. So that will still need to be extensive and
Extremely.
intensive at the same time
Yeah.
in terms of
Yeah.
testing.
Yeah. So that is again one phase of testing. But here, when I say adversarial learning, training, right, it is specific to those models. So
Yes.
when we design the model, right, there's a lot of training thing and the testing of that model itself. Not only security testing, it's how the model is stable, whether the model is stable, how it performs, is it what is level of accuracy it has, and in that context, we also add the security training aspect of the model itself, which is the core of everything. So that is something on a very technical level has to happen. Of course, what you speak, that also is important, but that is second stage. First stage is when you're developing the model, these things are most important.
Okay, so this is just to add an observation. I think we've been dealing with application system software where we know exactly what is the input and what the outcome is going to be, right? It is expected. These are first kind of systems, and why they're special is because the outcome is not deterministic in the sense it could be anything. It will be accurate, but it will still be anything, and it could be different. It could vary from what two people are expecting it to say, right? And that is what makes it so special in terms of security. But while you were talking about the training data and all of that, when you correlate that and actually extrapolate that further, there are, you know, various entities creating these models as of today, and many of them are private entities, some of them are public, some of them are open source. You know, you'll find all kind of combinations, just like we had with applications. Now there could be state actors, there could be threat actors, there could be so many others who would want to actually have intentionally fed data to training models to give a certain kind of output for anybody and everybody who's using it. This means it could have huge geopolitical implications for users. It could create biases, like not the ones that you were talking about, but actual human biases based on the information that they get from the model. What kind of implications did you see that will be on the receiving end for, like, for states, for organizations that are using it, and also for individuals?
When you look at this particular training from the nation or nation state, what are the threats that you have, right? Eventually, the one thing that happens, right? First of all, the infrastructure that you're developing the model, right, which is very critical at this moment, right? The thing when you're developing a model, right, from a security point of view, a particular format has to be, custom format is much needed at this moment. When I look from the reversing those models, right? So there are a bunch of the formats available in the market when you do reverse engineering on that, right?
Can you explain format a little? For the audience?
So when you go to this typical models, right, there are formats like SIFT tensors are there, which is generally used in GPT-4s, your llamas. They have this in which the format in which the model is stored. Like you have the binary files, typical different formats binaries, the formats for the machine learning, deep learning, these models over there, right? There is open neural network exchange, open source format for that, right? ONNX, and there are multiple formats over there. I think we should focus on, having a custom format in such a fashion that it's become very difficult to reverse engineer on that, right? That is one aspect. And another thing is, of course, one level of security is model obfuscation, which is a couple of organizations started working on that. So one of the famous architecture in neural network called as a GAN stands for Generative Adversarial Network. The creator of that, his name is Dr. Ian Goodfellow. He keeps on switching between Google and OpenAI, right? And he also created the model obfuscation library for it. Right? So you can obfuscate your model in that context as well, right? So that is something you should start doing at the background before it goes to the threat actor. So the custom formats and obfuscation is something at this moment is kind of a countermeasure, so that it becomes hard for an AI attacker to break that.
Yeah, I think it will take us at least a few more years till we start breaking this. But just the mindset, the offensive security mindset comes into it again and again. But I'm sure we'll be able to push it for a few more years, and it makes a lot of sense, because if reversing it is so easy, imagine all the others who are actually trying to be ambitious and develop something custom for themselves. Compromising something like that can have real world impacts for them as well.
Yes,
So
that's a good
makes a lot
point
of
you
sense.
brought, Nilu. The thing is, like, if you look at the different applications that have been released now, which speaks about, okay, we have released this Gen AI kind of application, right? At the background thing is like they're using some ready-made model,
Exactly.
right? And they're fine-tuning it.
We're going back to the application lifecycle again, right? The libraries
Right, so
and
everything there,
coming
but
back.
the model itself has the vulnerability. Whatever superb application you built, you still have that vulnerable zone. So eventually, if that particular model is compromised, and if you the attacker gets to know, okay, who all are using that model, finished. So
Actually, the way I've observed this space, it's not too much hype, because in applications, you know when the exploit happens or you've been compromised. But I think in many of these cases, right, knowing that itself will be very difficult, because things can be so subtle given the relationships and the weights and biases, the way they work out towards the end of it. It could be a genius mind that's trying to tamper with this, and then subtly figuring out what is the real impact, what is the bias. It could be a little bit of a bias, it could be a little bit of a privacy issue, but then that scales up depending on how many people are using the model. So that is why it is so special and it's so exciting. And I think I have way more questions, but in the interest of time, I'll stop it here.
Sure.
Any last words for passionate AI researchers?
That's AI researcher. I think the thing is, like, when you go from AI reversing, right? Don't limit to application security. You have to understand the domain. You have to understand the mathematical, because when you are reversing the AI, you are dealing with the mathematics. So now there are no more your typical encryption kind of reversing. This is the mathematical vulnerabilities, and you need to understand those maths well. So AI security research should understand the mathematics.
Yeah, so maths researchers will be now in demand.
Yes, very much, very much.
So, okay, jokes apart, but thanks a lot for joining us on.
Thanks for the invitation, Nilu. I am very happy to have this discussion.
Okay, thanks everyone for joining us on Breakpoint today. We'll see you all in the next episode.
Thank you, everyone. Bye.